5-4 exponential and logarithmic equations. Notice objective number 1. What's it say? Solve what? Simple. I told you everything we do in class is simple. Solve. Hey, shh. We're not on that line yet. Solve simple exponential and logarithmic equations. Then we're going to solve more complicated equations, exponential. Then we're going to do some logarithmic equations. We're just going to skip that word. We're going to use exponential and logarithmic equations to model and solve real life problems. Okay, so if I gave you the equation, hello, x minus 4 equals 10, what would you do to solve that equation?
10 minus 4.
You would do what? You would add 4 to both. Why? Why would you add 4?
Because you do the opposite of it.
Okay, because adding is the opposite of this, right?
Why would you not do 10 minus 4?
Because you're trying to get x by itself, so you would add 4 to both sides. Okay. How would you get y by itself? Divide by 6. Why? Okay. Because those are opposite operations, right? Inverse operations. Okay. Exponential, logarithmic. What are exponential and logarithmic equations? They are opposites. Okay. So we will be taking the log of both sides. We will be exponentiating both sides. Okay. That's what we're doing. It's not a big deal. So it is something new. It's just a new concept. It's not that big of a deal. 2 basic strategies for solving exponential logarithmic equations. The first one is 1-to-1. This is used to solve simple exponential and logarithmic equations. For instance, if I said that e to the x was equal to e to the 7th, what's x? It's 1-to-1. We know that if e raised to a power, then the powers have to equal each other. 1-to-1. The second is based on the inverse properties. A has to be greater than 0, but it can't be 1. And the following properties are true for all x and y for which log base a of x and log base a of y are defined. 1-to-1 properties. Any base raised to a power is equal to the same base raised to a different power means the exponents are equal. 1-to-1 for logarithms. The log, I don't care what the base is of something, equals a log same base of something else means x and y have to be equal to each other. So that's all there is to 1-to-1 properties. Inverse properties. If I take some base, call it a, if I raise it to log base a of x, the answer is simply x. So when this happens, what I look at is I'm like, okay, a raised to the log base a, basically that's going to cancel. So that's gone. So I get x equals x. Makes sense. Same is true with logarithms. See if y'all can answer. The second period couldn't. Log base a of a to the x power. Can y'all do anything with that? Ignore the right side. Log base a of a to the x power. Can we do anything with that? What property can we use on this? Y'all don't remember? We take the exponent and pull it to the front. Remember that? Okay. Second question. What is the value of log a base a? Log a base a. 1. Okay. On your calculator, if you were to type log 10 and press enter, what's it tell you? On your calculator, what's log 10? It's 1. Why is it 1? What's the base for log 10? The unwritten number is 10. What if you were to do natural log of e? What do you get? What is the base of the natural log? You might have to put the e to the first power. Better be 1. It's 1. because when you're dealing with natural log, the base is e, right? So this is one of the properties. So let's think about this. If log base a of a to the x power is equal to x, if we did the math involved there, that exponent of x would come to the front. Log base a of a is 1, so we have x times 1, which is x. So again, the way I look at it, if I see log base a of a, basically that's going to cancel, that's 1. Strategies for solving exponential and logarithmic equations. Number 1, rewrite the original equation in a form that allows the use of the one-to-one properties of exponential logarithmic function. Can I write it? Can I make it a one-to-one? If I can make it a one-to-one, I can set the exponents to equal each other. I'm good to go. If I can make it a one-to-one, I could set the thing on the logarithms to each other and solve that. I'm good to go. Number 2 and 3 are exactly the same. Rewrite the exponential in logarithmic form and apply the inverse property. Rewrite the logarithmic in exponential form and apply the inverse property. So it's just going back and forth between exponential and logarithm and making applications. And let's just jump to some problems. Let's talk through these. 2 to the x power is 32. Hopefully you're starting to learn some powers, you know, and hopefully you see the number 32 and go, oh yeah, 32, that's 2 to some power, 2 to the 5th power. 2 to the 5th power is 32. Well, if 2 to the x power is equal to 2 to the 5th power, then obviously x is 5. Because 2 to the 5th power is 32. That's a one-to-one property. So we took 2 to the x equals 32. We rewrote it, 2 to the x equals 2 to the 5th. That's a one-to-one. Part B, the natural log of x minus the natural log of 3 is equal to 0. To set things to one-to-one, if there are 2 log functions or 2 log pieces within the function, you need to get 1 log to the left side, 1 log to the right side. If I can get a log on the left and a log on the right with the same base, then I can set it as a one-to-one. So log base, natural log of x minus the natural log of 3, add natural log of 3 to both sides. I now have natural log of x equals natural log of 3. Well, obviously x has to equal 3, one-to-one. Part C, when you start getting into fractions and stuff, it might not be as intuitive at this time, but the more you practice these, the more that'll make sense. A fraction can be rewritten with a negative exponent. So 1/3 is the same thing as 3 to the negative 1 power. 9 is the same thing as 3 squared. So, and since it's x power, it's going to be 3 to the negative x equals 3 squared. Therefore, is equal to 2. If negative x is equal to 2, multiply both sides by -1, x equals -2. Part D. So A, B, and C were all converted to one-to-one. D through G are all inverse properties. On letter D, e to the x power, my variable is an exponent. Therefore, this is exponential. What is the base of e to the x? E. So to get rid of that e, I'm going to take the natural log of both sides. If I take the natural log of the left side, I have to take the natural log of the right side. So natural log of e to the x equals natural log of 7. Power properties, that x moves to the front. What is the natural log of e? 1. So I have x times 1. So obviously x is equal to the natural log of 7. Folks, if I have the natural log of 7, know that that is a number, okay? Natural log of 7 is just a number, so that is the answer. This would be considered an exact answer. If I was doing some computation with it and I wanted to a value for whatever reason, I might want you to approximate the natural log of 7, which of course would use the calculator. E, F, and G are basically the same. I have 3 problems with 3 different bases. I have a natural log, a log base 10, and a log base 3. If I have a log, to get rid of the log, you use the base and make the log the exponent. So an example E, The base happens to be e. So natural log of x equals -3. If I make natural log an exponent and I make -3 an exponent on e, I exponentiated the problem. I made what I had exponent. What is e to the natural log? It basically cancels. So x is equal to e to the -3. And the same is basically true for the rest of the problems. I'm going to walk through those. Y'all can look at those, and if you want to talk to me about it, come talk to me. Solve each equation and approximate the result to 3 decimal places if necessary. Letter A. Any ideas? Okay. We have e to something on both of them. So how are we solving this?
You take the square root from both sides.
Mm-mm. Right. This is 1-to-1, right? This is a 1-to-1 situation. If e to some power is equal to e to some other power, the only way that is true is if those powers equal to each other. So for letter A to solve it, I'm going to write -x squared is equal to -3x minus 4. What's that look like? That's just a quadratic. So step number 1 in a quadratic is to put it in general form. So I will add x squared to both sides. 0 equals x squared minus 3x minus 4. That factors very easily. I'm not going to spend any time talking about it. That factors into x minus 4 times x plus 1. I've got two factors that multiply together equaling 0, which means either x minus 4 equals 0 or x plus 1 equals 0. So x equals 4, x equals -1. I'm not going to spend any time doing what I'm about to tell you need to do. Okay. You should always, when you're doing this, check your answers. Take the answers that you got, plug them into the original equation, and see if it's true. You can and will get extraneous solutions. It is possible you do all the algebra exactly right to find out none of your answers work. So it's possible for no solution. Okay. D and E does not exist. Okay. I believe these work. Part B. Any thoughts on what you might want to do first to solve part B? Absolutely. Divide both sides by 3. Left side becomes 2 to the x power. Right side becomes 14. Can you write 14 as a power of 2? Can you write 2 to some power to get 14? No. I mean, 2 cubed is 8, and 2 to the 4th power is 16. Didn't work. So I cannot do 1-to-1 on this. What kind of a problem is this one? Exponential. This is an exponential equation. What is the inverse of exponential? Logarithmic. What is the base on the problem that I'm looking at? Base is 2. So what I'm going to do is I'm going to take the log base 2 of both sides. So log base 2 of 2 to the x power is equal to log base 2 of 14. Log base 2 of 2, what's that? That's 1. So the x comes out front. Log base 2 of 2 is 1. So I now have x equals log base 2 of 14. Now at this point here, I mean, I could type that in the calculator exactly like it is and get an answer. Or we can use change of base. I like to be lazy. So if I'm doing a change of base, I'm always going to convert to natural log because that's only 2 letters and log is 3. Okay, so I can write that as x equals natural log of 14 divided by natural log of 2. And again, folks, it doesn't matter. You could enter either one of these into your calculator. If you're not using the TI-84, one of the more sophisticated calculators, you need to do the change of base and change it to natural logs. Wrong button. Whatever. So if I did natural log of 14 divided by natural log of 2, I get this answer. If I went math up to log base 2 of 14, what do I get? Better be the exact same thing. Or I could have done log. It doesn't matter. Log 14 over log 2. And that's the significance of change of base. You can change to whatever base you want. So the answer to this one is about 3.81 or something like that. 3.807. Okay, thank you, sir. It's very important to read the instructions. Otherwise, the computer is going to say you got the problem wrong. You got to start over. Questions? There's the first problem I did. And again, check these in the original equations. I'm not going to spend any time doing that. I'm hoping at this stage of your life, mathematically, you can plug numbers in and see if you're right or wrong. Part B, 3.807. Check it in your calculator. When you're checking something like this, the original equation, don't put 3.807 in for x. Actually type log base 2 of 14 in for x. To solve a logarithmic equation, you can write it in exponential form. Natural log of x equals 3, that is logarithmic form. E to the natural log of x equals e cubed, that's to exponentiate both sides. Did I skip a problem? No, that's just showing you how to solve it. So the original problem is natural log of x equals 3. If I want to get x by itself, what's the base for natural log of x? E. So because the base is e, I'm going to make those exponents. So natural log of x becomes an exponent, 3 becomes an exponent. E to the natural log basically cancels. So I'm left with x equals e cubed. So that is what we do. We exponentiate both sides when you make both sides exponents. Okay, natural log of x equals 2. Let's solve that.
E raised to the x.
Not to the x.
E raised to the natural log of x equals e raised to the second.
Pardon this quick interruption, but due to possible weather, baseball is going to be moved up, so the baseball players will be excused at 2 p.m. So we'll make an announcement for all baseball, varsity baseball at 2 p.m. when that time comes.
In case you can't remember, in 7 minutes you're leaving. Okay.
Check that. We won't make it just at 2 o'clock straight. We'll send them out to go to the bus.
Okay, now what? Okay. E to the natural log cancels, so x equals
E to the second.
e squared.
Commissioner Thorpe, looking a bit too complicated.
That's difficult.
Oh no, the next one.
Okay. Letter B, what do we got going on here?
Well, they both have a log base of 3, so can't you just set them equal to?
Yeah, it's
Yeah,
log base
5x.
3 of some junk, right?
Yeah, 5x.
Just means the junks equal the junks. 5x minus 1 equals x plus 7. Basic algebra.
Is that it?
Subtract x from both sides. Add 1 to both sides. Divide by 4.
X equals 2. That looks a lot.
And again, check your answers. I'll go ahead and clear this. Moving on.
It all has log 6 as the base.
Good. So just ignore the log 6's, right? And have 3x plus 14 minus 5 equals 2x?
Yes.
Nope.
No?
Nope.
Because it's a minus, so it wouldn't make the, then move whenever you went over, like, the log 6, 5 over to the right.
Okay, great. Now we got 1 on the left and 2 on the right.
Oh, okay, you didn't add those together? Oh, no.
Could you multiply the 5 times the 3x, the negative 5 times the 3x plus 14?
No?
Isn't it? So for, whenever you have a minus,
Okay.
whenever you're doing a minus, isn't that whenever you're doing the division? So
Yes.
can you not do log base 6, 3x plus 14 divided by log base 6 of 5?
No.
Or is it the opposite?
No. Now you're headed in the right direction, but you goofed. You made a big mistake, and it's a very common mistake.
So it's great.
Okay. When you can, this is a difference of logarithms. A difference of logs is equal to the log of the quotient. I didn't say the quotient of the logs. I said the log of a quotient. So this log is positive. So I am going to stay in log base 6. Because this log is positive, the 3x plus 14 goes on top. Because this log is negative, the 5 goes on bottom. I do not write log twice, which is what you said.
Oh,
Okay, there's only one log statement. By doing this, I now have one log statement on the left and one on the right.
Now can we cancel all?
Can we?
Yeah.
Can we go 1 to 1 now?
Yeah.
Absolutely. So we have 3x plus 14 over 5 equals 2x. And now we're down to basic algebra 1, maybe even 8th grade math. Multiply both sides by 5. Subtract 3x from both sides. Divide both sides by 7. And of course, I would want to go back, check that answer in the original. Okay. Questions on that?
No, sir.
Doubling an investment. You invest $500 at an annual interest rate of 6.75% compounded continuously. How long is it going to take you to double your money? What is the formula for continuous compounded interest? A equals what?
PE raised to the RT.
Physical education raised to the RT power. Okay, beautiful. What's A?
Amount and
1,000. I don't see 1,000 in the problem. Where'd you get 1,000? If you're going to double your money, remember A is after. A is the amount of money you have after it's been compounded. If I want to double $500, I now have 1,000. P, principal. How much money did I start with?
500.
500. What is E?
E
E is just E, right? Okay. R?
interest rate. So
0.0675. What is t?
Time.
We don't know. Bye, baseball. Okay. What would you like to do this problem?
Can we not like?
That's eventually, yes. What's the next logical step? Divide both sides by 500. 2 equals e to the 0.0675 t. Where's my variable? Exponent, which means it's exponential. How do I get the exponent out of the exponential? Okay, it is logarithm, but because the base is e, it's going to be, I'm going to take the natural log of both sides. So the natural log of 2 is equal to the natural log of e to the 0.0675 t. Law of logarithms says that I can take that exponent, move it in front of the natural log of e. Natural log of e is 1. Okay, so I have natural log of 2 is equal to 0.0675 t. Natural log of 2 is just a number. I can find that value by typing it into my calculator, but I don't care about that right now. To get t by itself, divide both sides. So I have t equals natural log of 2 divided by 0.0675. That would be the exact answer. And if I asked you how many years is it going to take to do something, if you tell me the answer is natural log of 2 divided by 0.0675, I'm going to say, what does that even mean? You type that in your calculator and you get t is about 10.3. What? Years. Do what? 10 years to a 16-year-old, 17-year-old is a lot longer than 10 years is to a 50-year-old. 10 years is over half of y'all's life. 10 years is only 20% of mine. Questions on this problem? Okay. There it is, worked out with explanations beside each step. There's a graph of what it would look like, which I don't know why they included that. They didn't ask for a graph. And that's it for 5-4.